Hey everybody, and today we're going to be talking about parabolas. Now I know that Unit 5 was all about quadratics and parabolas. However, in this case, we're going to be talking more about the way that the parabola is shaped. Okay, so let's take a look here. We have a parabola, and you guys are familiar with its U-shaped graph. Okay. We also have what is called the axis of symmetry, which goes right down through the vertex. In this particular case, it happens to be the y-axis. Okay, there are two new things here. One of them is called the focus. Okay, the focus is a fixed point. And there's also something called the directrix, and it is a fixed line. Okay, what we know about this is that they are equidistant from the focus to any point on the parabola, and the parabola to the perpendicular point on the directrix. These are going to be equal length, these two distances. And that's going to actually help us create the formula for a quadratic. So each parabola has one axis of symmetry, and it's going to connect the focus and the directrix. So notice that this axis of symmetry that I drew here went through the focus and the directrix. Okay? The axis of symmetry actually meets the directrix at a perpendicular line. So how does this all look in real life? Okay, what we have here is a focus, which is our fixed point, and then this line is our directrix, or D. Okay, what happens? Okay, and this is labeled M. Excuse me. The label M it stands for midpoint because basically the focus to this point and this point to the directrix are going to be equidistant, and we know that based on the notes that we just took on the previous slide. So, if I were to take this and drag the point along the directrix, notice what happens. Okay, I get a parabola. And look, if you look up here, you can double check that the length from DM, from the directrix to the midpoint, and from the midpoint to the focus stay the same length no matter where I go. Okay? So if I want to clear this and try something else, let's see, let's move the focus closer to the directrix. Okay? When I move the focus closer to the directrix, watch what happens now. It becomes more narrow, doesn't it? Okay, now if I erase that and put the focus way up here, okay, it becomes a much wider parabola. Okay, so this is for when the focus is above the directrix. We can actually have cases where the focus is below the directrix. Now watch what happens when that happens. So when the focus is below the directrix, we have a parabola that opens down. Okay? So that point right there, that M, is creating a parabola that is equidistant from the focus and the directrix at every point. That's how parabolas are created. Alright, so what we're going to do is we're going to derive the equation of a parabola using the distance formula. Okay, remember that the distance formula is on your formula sheet, so you're not going to be required to memorize it. Okay, it says use the distance formula to find the equation of a parabola with a focus of 2, -1 and a directrix of y equals -5. Now I've already taken the time to draw this graph for you. It's not always going to be this way. You're just going to get some information and you have to think about the graph. So 2, -1, this is my focus right here. I have a line y equals -5. So I know this parabola will open up because the focus is above the directrix. I also know that the distance from the focus to this point P on the parabola is the same length as the point P to the point D on the parabola. Okay? That's going to be very important in just a little bit. Alright, so here you'll see that we have a very large blank space. This problem will take us a length of time. Usually when you see the word derive, it will take us a while. So what we have here is the distance formula, okay? And what we're going to do is we are going to look at the distance from the focus to P and P to the directrix. Now, notice I have 2, -1 for the focus, x comma y for P, and I need a point for D. I know the y value is -5, but I don't know the x value. However, I know it is perpendicular, it's straight down from P, and P has an x value of x. So I have 3 points. We have the focus, which is 2, -1. We have P, which is a point on the parabola, x comma y could be any point, and we have D, the point on the directrix, x comma -5. It is our job to find the distance from F to P and P to D, because they are the same and we can set them equal to each other. So let's go ahead and find the distance of FP and PD. I want you to pause and use the distance formula now. Alright, so using FP, I found that the distance is x minus 2 squared plus y plus 1 squared, all square rooted. Be careful here, there was a -1, so y2 minus y1 minus a -1 becomes a +1. Alright, and then PD, we have our 2x's squared plus y plus 5 squared. Now what's nice about this is that x minus x is 0, and 0 squared is 0, so we can actually cross that out and get rid of it. So what we have now is we have the left side x minus 2 squared plus y plus 1 squared equals the square root of y plus 5 squared. Now I don't like the square roots on both sides. If I were to square both sides, I would get rid of the square roots. So let's do that. So I would be left with x minus 2 squared plus y plus 1 squared. And that will be equal to y plus 5 squared. Now in the equation of a parabola, it's always y equals something. So let's go ahead and move all the y's over to one side. I'm going to begin by subtracting this whole binomial y plus 1 squared. And I'm going to do that to both sides. Whoops. I get a parentheses. So we have x minus 2 squared on this side is equal to y plus 5 squared minus y plus 1 squared. Now we can actually combine like terms here. The first thing you need to do is you actually need to distribute these two binomials. Remember the FOIL or the box method from units 4 and 5. Okay, so let's make a side note. Y plus 5 times y plus 5, which is y plus 5 squared, is y squared plus 5y plus 5y plus 25, which is y squared plus 10y plus 25. Okay, so that's our first one. Then the second one is going to be y plus 1 times y plus 1. So y squared plus 1y plus 1y plus 1 gives me y squared plus 2y plus 1. So we are going to be subtracting a y squared plus 2y plus 1. The left side's going to stay the same because we didn't do anything to it. Now here's the deal. Remember that whenever we are subtracting two polynomials, we have to distribute the negative sign and add them. So y squared plus a negative y squared is 0. 10y plus a negative 2y is 8y. And 25 plus a negative 1 is 24. Okay? Now we are actually going to leave this x minus 2 squared in parentheses because this is what it looks like in the vertex form. So now all we have to do is solve for y. First thing I would do is I would divide this whole side by 8. I notice that 8 will go into 8 and 24 evenly. So what I have here, let's scroll down and make some more space, is 1/8 x minus 2 squared equals y plus 3. I can now subtract 3 from both sides, and I get 1/8 x minus 2 squared minus 3 equals y. So if I take a look at this, 1/8 is the A. It tells me that this parabola is wider. I can also see that the vertex is 2, -3 because this right here is in vertex form. You can even write it like this, 1/8 x minus 2 squared minus 3 Okay, that may look more familiar to you with the y appearing first. Okay, now this was a very, very, very long problem. Okay, take a look at that. I will tell you right now that you are required to know how to derive the equation of a parabola given the focus and the directrix. You are going to have to know this for your test, for your big test at the end of the year, for the milestone. You guys know this, okay? I wouldn't put you through all of this work if it was not a part of your standards, okay? However, there is a way that's a little bit easier that we will use more often than not, okay? And if you take a look, there are two formulas, and I actually pulled this directly from your formula sheet. You have vertical and you have horizontal. Okay? Oops. We are used to vertical parabolas, meaning they open up or open down. Horizontal parabolas can actually open left or open right. So that's new, but today we're only going to focus on the vertical. Okay? So what we need here is we need a K, a P, and an H. Remember, H and K is just the vertex, and P is going to be the distance from the focus to the vertex. So we take a look back at the original problem. This was 2, -1. This is the vertex, and this is the directrix. The distance from here to here is P. So is this distance, because remember, any point from the focus to a point on the parabola is the same distance as the vertex, or from any point on the parabola to the directrix. So what we have here is 2, -1. And this would be 2, -5, because we know that this is y equals -5 because that's in the problem. So what I need to do is find the distance between the vertex and the focus. But the vertex is the midpoint between the focus and the directrix. So if I take the focus and I take this point, the directrix, 2, -5, and I find the midpoint, that will be the resulting vertex. Okay? So let's do the same problem. The equation that we're going to use is y minus k equals 1/4p x minus h squared. And the reason we're doing that is because this is a vertical parabola. And if you go back to the previous slide, this is the equation for vertical parabolas. So what do we need? We need a vertex, which is hk, and we need the value of p. So we find the vertex, like I've already said, using the midpoint formula. So by taking the point, the focus, and the directrix point, which is directly below the focus, we can find the midpoint, add my x's, divide by 2's, add my y's, divide by 2. The midpoint, or the vertex, is 2, -3. So I know that -3 is going to go in for k, and +2 is going to go in for h. The only thing I need now is p. So P is going to be the distance from the focus to the vertex. So we can actually subtract these these y values. Notice that the x value for the focus and the vertex are the same. If I subtract those, I just get 0. We know the distance is not going to be 0. So the y value of the focus is -1, and the y value of the vertex is -3. So 1 plus 3, or -1 plus 3 is 2. So we have a p value of 2. So now we know, plug in 2 here for p. So we have y minus k, so y minus a -3 is y plus 3. 1/4 times 2 is 1/8. X minus 2 squared. And that right there is the equation of the parabola. That was the same exact problem that we did on the previous slide here that took us all this work, okay? However, you still have to know how to do that in order to derive the formula. Okay, that's it for today's lesson. However, there will be another video that goes over the second you try problem where you have to derive the formula. And it will also go over this question, the second you try, that where we'd have the shorter method. So I want you to go ahead and watch that. That way you can solidify your understandings of writing equations of parabolas. See you soon.